All right, hi everybody. This is the Math 31 integration review. This is question 2. What we got to do here is we got to figure out what the function f is. Given a little bit of these kind of parameters here, we know that the derivative of f is 2x plus 5 to the 3 halves. So the antiderivative, okay, well, this is something we can kind of guess at here. We're going to increase, that we're going to increase the exponent by 1, so this will end up being 2x plus 5, okay, to the 5 halves, and then we're going to divide by 5 halves. But if you were to take the derivative of this, you would bring down the 5 halves. The 5 halves would cancel. You'd end up with 3 halves here. But then you would multiply by a 2. So what that means here is we need to now divide this whole expression by 2 as well in order to make this work. And then don't forget about plus c. Okay? Now, when we kind of simplify what we're seeing here, we see that we're going to end up with 2x plus 5 all to the 5 halves all over 5. In the denominator here, that 5 and the 2 fifths, sorry, the 2 and the 5 halves are going to cancel. But remember, this is still plus c. Now, what we're going to do to figure out what c is, because we do have this one little bit of information here, we know that if we evaluate this at negative 2, the answer should be 2 fifths. So if we evaluate what we've got here at negative 2 and plug that in, okay, so that'll be 2 times negative 2 plus 5 all to the 5 halves over 5 plus c. Okay, I know that this should equal, and I'll just put this over here, I know that that should equal 2 fifths. Now let's just take a look at this. 2 times negative 2 is negative 4, plus 5 is 1, 1 to the 5 halves is 1, so 1 fifth plus c is equal to 2 fifths. So 1 fifth plus c is equal to 2 fifths. I think it's pretty clear that we know that c has got to be equal to 1 fifth. Now that allows us to write, therefore, to conclude that f of x must equal 2x plus 5 to the 5 halves all over 5 plus 1 fifth. There's our expression for f.